Hi everyone, this is the final paper from November 2019. I'm going to take you through this so that you can see how I would answer these and to allow you to practice these just before our exam. So, calculator paper, expand and simplify that. So we're going to just do x squared minus 9x plus 5x minus 45. And that will give us x squared minus 4x minus 45. Factorize this, it's got a 3 and an x in both, so we make that 3x brackets 3x plus 2. Use your calculator to find that out and write down all the figures on your display, so you just have to copy that into your calculator. Square root of 35 minus 1.9 cubed, 157.668,255. And round this to 4 significant figures, so 157.7. There's the 4th significant figure there. The next digit is above 5. Okay, scatter graph. Jamie got a mark of 34. Find his mark in the math test. Okay, so we need a line of best fit here. And in order to do that, we need to try to get the same number of points on either side of the line. So maybe something like that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 on each. Something like that. So now we can read off the graph. Let's go up at, 34? In science, which is here. And go across. So I would say that's 40. Okay, frequency, grouped frequency. So we know that we need to do the midpoint, which will give us our x column, 7.5, 12.5, 17.5, and 22.5. And we would multiply those fx in this column here. So 7.5 times 2 is 25. 17.5 times 7 is 122.5. And 22.5 times 8 is 180. Add those all together is equal to 335. And we're told in the question that there's 18 students. So we divide that by 18 to get 18.6 seconds to 3 significant figures. For question 5, we have 37 centimeters cubed. So let's draw a cube. It's not to scale, but we're going to pretend that the volume is 37. So 37 centimeters by 1 centimeter by 1 centimeter will give us a volume that we need. And we're going to now turn that into millimeters. So 370 millimeters, 10 millimeters, and 10 millimeters. So now when we times these all together, we get 37 and 3 zeros millimeters cubed. Okay, Nima was driving to a hotel, looked at sat-nav at 1:30, arrived at the hotel at 14:48. So that's, if we subtract those, we've got an hour and 18 minutes. And we need to convert that into hours. So on your calculator, there is a time function which looks like a circle, a comma, and then double quotes. So I just want you to type in 1, then that button. It should look like a little degrees sign. Then 18, and press it one more time. So you've got 1 degree, 18 degree. Press equals, and it should show you 1 degree, 18, then a sort of like an apostrophe, and then a 0 and a double quote. So that's 1 hour, 18 minutes, and 0 seconds. You can now press SD and that converts it into a decimal for you. So 1.3 hours. So now we can use our formula. Speed equals distance divided by time, 65 over 1.3. 65 divided by 1.3 is 50. So it would take 50 miles per hour. Okay. That number in standard form, we need it in a decimal between 1 and 10. And that would be there. So 1, 2, 3, 4, 5, 6, 7. 3.246 times 10 to the 7. And then the opposite way for the minus. So the 496, 1, 2, 3. We put zeros under 1, 2, 3. Yeah. 0, 0. Sorry, that's not very clear. Let's do that again. That was terrible. So we'll go 1, 2, 3. So the first one just in front of the 4, so it's only 2 zeros there. 0.00496. Asma was asked to compare the following two numbers. She says 6.2 is bigger than 4.7, so A is bigger than B. Is Asma correct? No, because she hasn't taken into account the powers of 10. So if you wanted to compare them, you'd make them the same power of 10. So this would be 47.3 times 10 to the 8 compared to 6.212 times 10 to the 8. Or you could write them out in full, or you could just talk about that being 10 times bigger. Diagram shows a regular pentagon and a parallelogram. So work out x. So this angle in here, because it's a parallelogram, you can imagine the Z and F angles, but essentially you add these two to get 180. So 117, that would be a 63 in there. And then we need the interior angles of a pentagon. So 5 minus 2 times 180 over 5 would be each individual angle. That's 540 over 5, which is 108. So to find x, we do 108 minus 63. 5, 10 minus 6 is 4. So we've got 45 degrees there for x. Enlarge triangle A by scale factor 2.5. Okay, so 2.5, we're going to go from the center of enlargement. We'll just draw our lines out there, and let's move that so it's a bit more accurate. It's hard to do on this. And then we can draw lines going from here. Okay, so in order to plot this then, let's take one of the corners, let's say this bottom corner here. That's a distance of 2 squares away from the center of enlargement. So we're going to times that by 2.5 to give you 5. So the total distance away from that should be 5 squares. 1, 2, 3, 4, 5. That's going to go there. Same sort of thing for this, but it's got to be in line with here. So we go upwards and it hits there. So my line's slightly out there, I think. Yeah, I think if that line were to go a bit more like that, probably be a bit more accurate. And then same for this one. It's going to be in line with this. Let's see if we can get it a bit more through that vertex. Yeah, something like that. So when we draw our new shape, then it's going to go through these points like that, through there, and then like that. So yeah, it's slightly too big. So yeah, it probably is maybe going across there like that instead. So you can actually check these as you're doing it, because the distances should be 2.5 times bigger. So it would be more like going through there. For question 10, we have an equation that we can solve here. So we're going to multiply both sides by 7, and then we'll get 9 plus x equals 77 minus 7x. Take the 7x over to get 8x equals 77 minus 9 is 68, and x equals 68 divided by 8, which is 8.5. Okay, you can check that on your calculator by using the equation buttons. If you haven't done this before and you've got the white calculator, the FX991EX class whiz, then you can actually type this equation. Let's do 9 plus x over 7. And then instead of the equal sign, press the alpha red button, and the calc button you'll see, which is just underneath it, will give you a different type of equal sign there. Then 11 minus x. And instead of pressing the normal equal sign, we press shift and calc. So this will solve this equation for us. If you've done this correctly, you'll have an x equals, and then if this is the first time you've done it, there'll be a 0 there, but it'll be in a black background. And you press the normal equals one more time. And if you've done it correctly, you'll have an L minus R equals 0. That tells you that it's worked out the answer to this equation, and this x equals 8.5. So you can use this to solve equations in the exam, which is pretty good. Question B, we're just going to cancel the y plus 3 squared with 2 from the top and get 4 brackets y plus 3. For question 11, we have a probability tree, and we want to work out the probability that we late on exactly one of the 2 days. So we're going to go late, not late, and not late, late. We can simply multiply these together, 0.07 times 0.98 and 0.93 times 0.11, and add those two results together. So we've got 0.07 times 0.98 plus 0.93 times 0.11, and we get 0.1709. That's the probability that they'll be late on exactly one of the 2 days. Okay, Stemleaf, this is only for GCSE. We need to turn that into a box plot. So the bottom of the box plot is the lowest number, which is 173. So that's going to go like there. The highest value is 219. Okay, so we can draw a line going across there. Oops. Like that. And then we now need to find out the median. So as we have 23 sunflowers, we work out the median by adding 1 and then dividing by 2. That will give us the position of the median. So 23 plus 1 is 24, over 2 is 12. So we need to find the 12th position. 1, 2, 3, 4, 5, 6, 10, 11, 12. So the median is 197. That's going to go there. And then, so if the 12th position is the median, that means the 6th position is going to be lower quartile, and the 18th position will be the upper quartile. So the 6th position will be 188. So that would be there. And then the 18th position, so that's 12, 15, 16, 17, 18, will be 209. So that will be our box plot for this stem and leaf diagram. Liquid A and B are mixed together in a ratio 2 to 13 by volume. A has density in that. Okay, a cylindrical container is filled completely with liquid C. Okay, so we can work out the volume of liquid C, which is equal to pi r squared H. So that is pi times the radius squared times the height. 25 times 9 is 225 pi. So that's the volume of the liquid, and it's shared, well, it's mixed together in a ratio of 2 to 13. So the volume of A to volume of B is in a ratio of 2 to 13. So we're going to split 225 pi into 2 to 13. So add the ratios together to get 15 and divide 225 by 15. So 225 is 15 squared. So that's divided by 15 is just 15. So I'm going to times both of these by 15. So we get 2 times 15 is 30 pi. And then this one is 195 pi, like that. So that's how much volume we have of each liquid. And then we're asked to find out the mass of the liquid. So we're going to use the formula density equals mass over volume. And rearrange that to get mass equals density times volume. So the mass of A is the density, which was 1.21 times its volume, 30 pi. And the mass of B is its density, 1.02 times by its volume of 195 pi. So mass of A, 1.21 times 30 pi is 363 pi over 10, and 1.02 times 195 pi equals 1989 pi over 10. So when I add that together, I get 1176 over 5 pi. And so that will be the complete mass to 3SF. Let's just put that in a decimal. 739 grams to 3SF. Okay. Question 14. The number of people who chose soup to the number of people who chose prawns is 2 to 3. So what we can do is, let's say soup to prawns is 2 to 3. And then of those who chose soup, so let's do lasagna to curry is 5 to 3. And of those who chose prawns, lasagna to curry is 1 to 5. Okay, so that's kind of what we have going on here. So remember, with ratios, what we can do is say the number of people who chose soup initially was 2/5, because we add those ratios together. And then of those, 3 out of 8 chose curry. So we're going to multiply that by 3 over 8 to give us the proportion of people who chose soup first and then curry. And then for prawns, we got 3/5 times curry was 5/6. We can add those together. So cross cancel this, and we get 3/20 plus, that cancels a half. So 3/20 plus a half. Half is 10/20, so we've got 13/20 people who chose curry. Prove algebraically that the sum of the squares of any two consecutive even numbers is always a multiple of 4. So To get an even number, we always write 2n. We're going to square it. The next consecutive even number would just be 2 greater than that number, like that. So we're going to expand this to get 4n squared plus, double bracket this, 2n plus 2, 2n plus 2. We get 4n squared plus 4n plus 4n plus 4. And then we add that all together, we get 8n squared plus 8n plus 4. And whenever you're asked to show if something's a multiple of something, we have to take that number out as a factor. So we take 4 out as a factor, and whatever's inside this bracket, it doesn't matter what number it is, it will always be multiplied by 4. So that number will always be a multiple of 4. That's how we show it, by taking that number out as a factor. Okay? Y is inversely proportional to the square of x. So we write this as y equals k over x squared. And it says then y is equal to 8, x equals 2.5. So we're going to substitute those values in and rearrange. So k equals 8 times 2.5 squared, which gives 2.5 squared times 8 is 50. So we can rewrite this equation as y equals 50 over x squared. Now find the negative value of x when y equals 8 over 9. So we're going to substitute 8 over 9 in for y and try and find x squared. So times by x squared, we can cross multiply and cross divide. So we're going to do 50 times 9 over 8, because we've switched these around and took that up there. So 50 times 9, 450 over 8. 450 divided by 8 is 225 over 4. So that is x squared. So when I take the square root of that, we get plus or minus 15 over 2. Because 225 square root is 15. So they want the negative value of x. So we're going to put minus 15 over 2. Minus 7.5. Because we ignore the positive. Okay. Here's a graph of y equals x squared minus 3. Okay. Use the graph to find estimates for the solution of x squared minus 2x minus 2. Okay, so this is one of those tricky ones where we have our original graph of y equals x squared minus 3. I'm just going to line those up like that. We can write a 0x in there if you like. And the question is, how do I go from the original equation to this one? Well, I always have to subtract these two. Okay, that's just the rule. If you're not sure why that works, don't worry. But it's about when you substitute these values in for each other later on. But if I subtract these, I get x squared minus x squared. 0x minus 2x is positive 2x. And negative 3 minus 2. So minus 3 plus 2 is minus 1. So this always gives us the equation of the line we need to draw in order to find the solutions. Okay? So y equals 2x minus 1, what does that look like? Well, it passes through negative 1. And when y is 0, 2x minus 1. So I rearranged that to get x equals a half. So when y is 0, x equals a half. So there. And now I need to draw a line, a straight line that goes through both of those points. So let's try and estimate that here. Something like that, I'd say. Yeah, that's pretty good. And the whole point of doing this is that if you now read off the x values of these intersections, that will be the solution of the new graph. Something like that. So let's just have a look at what these points are. We've got minus 0.75 maybe? Minus 0. Yeah, it's closer to minus 0.8. And this one is 2.7. Okay, so in theory, those two are the solutions of our new equation. What most students don't realize is that you can actually solve that equation on your calculator. X squared negative 2x negative 2, and it gives us 2.73. So 2.73, that one's pretty good, and the other one is 1 minus root 3 minus 0.73. Minus 0.73. So yeah, minus 0.8. That's pretty close. Depending on the accuracy of it doesn't mention the accuracy in this one, so there'll be a range. But if you're worried about that, you can maybe adjust your line slightly so that it crosses over at minus 0.7 instead. Okay, diagram shows triangle ABC. D is the point on BC such that the size of angle DAC, that one in there, is 2/5 the size of angle BCA, that one there. So if we call that theta, this one will be 2/5 of theta, and we have to calculate the length DC. Okay, so if we're trying to find DC, then we need to know theta so that we can use sine rule on it later on. We have all three sides here, so we can find any of the angles in the triangle ABC that we want. So we might as well go for theta. Cos theta is equal to, that would make this A, and the other two would be B and C. It doesn't matter which way around they are. So 6.2 squared plus 6.1 squared minus 3.4 squared over 2BC. So put this into the calculator. Over 2 times 6.2 times 6.1 gives us 6409 over 7564. So theta is going to be the inverse cos of that, 32.080 degrees. So I'm going to store that in the memory because I can't simplify that anymore. This angle in here, 2/5 of theta, so I'm going to times that by 2/5 to get this one here of 12.83. And then I can find this angle in here by adding that to our original answer and taking that away from 180. 135.087. So store that in the memory as well. So now that we have all of those angles, we can find out DC because we can use the sine rule here. So if we do sine 135, I'll use the full value on my calculator. That's going to be over 6.2 because that's the opposite of that one. And we can do this one here. Yeah, that one there. So sine of 2/5 theta, which we have on our calculator, over DC, the one that we're trying to find. Okay, so we can rearrange this. DC is equal to 6.2 sine 2/5 theta all over sine 135. Let's see if that works. So 6.2 times sine 0.4 times that, and then we're going to divide by sine of our answer there. That's given us 1.95 centimeters to 3 significant figures. So hopefully that's right. I think that works. Question 19, we've got a distance time graph and work out an estimate of the speed. So how do we get a speed from a distance time graph? We have to take the gradient. As you can see, this is a curve. So at 6 seconds, let's read off the graph with this point here. We need to try and take a tangent at that exact point. So something like, well, let's take it up to there. It might make it easier. Something like that. Okay, and then we can work out the rise over run, if you want to call it that. Something like this. It's not easy to do on the computer, but you hopefully get the idea. The distance across is 3.4, and the height is 5, 10, 11, 12. So the gradient of that is 12 over 3.4, approximately 3.5 as an estimate. Okay, question 20. This is only for GCSE, this question, because it's a geometric series, which we don't have in IGCSE. But essentially, we're looking at the difference of these, and they're going 1, 3, 5, 7, and these all differ by 2, which means it's going to be an n squared graph. N squared sequence. So let's look at n. N is 1, 2, 3, 4, 5, and then n squared would be 1, 4, 9, 16, 25. So we're trying to look at the difference between the red and the pink one. So the difference between, that and the normal one. We've got a difference of 2, then 4, 9 minus 3 is 6, 16 take away 8 is 8, and 25 take away 15 is 10. So 2, 4, 6, 8, 10, that's going up in 2s, so that's 2n. So we've got to do n squared minus 2n. Okay. Question 21. When a bias coin is thrown 4 times, probability of getting 4 heads is 16 over 81. So probability of getting heads, and heads is 16 over 81. So this is the same number multiplied by itself 4 times. So the probability of getting a heads is the 4th root of 16 over 81, which is 2 over 3. So the probability of getting tails is going to be 1/3. And so the probability of getting tails 4 times will be 1/3 to the power of 4. So 1 over 3 to the 4 is 81. Okay, dividing a fraction. Let's try and factorize these as we go. So 7 brackets x minus 2. On the bottom here we have x, and we're going to have 6 and 2, so x plus 6, x minus 2. So you can see some of these cancel, and we're going to times and flip the second one. So we'll take x out as a factor, x squared minus 36 over x minus 6. So we can cancel straight away this and this. The x minus 6 is giving you a clue about this numerator here, so let's write that out again. Times difference of two squares, x plus 6, x minus 6, over x minus 6. See how I mentioned that this is a kind of clue that there's an x minus 6 hidden in there. So I'm going to cancel this, and then I can cross cancel the x plus 6 with the x plus 6 there. So I finish with 7 times x. Question 23, we have a sector OACB and it's folded up to make a hollow cone. Okay, so the cone has volume of that and a height. So that'll allow us to work out the radius. Let's do volume is a third pi r squared h. So 56.8 is equal to a third pi r squared, which we don't know, and the h, which is 3.6. So times both sides by 3, and then divide by 3.6 pi. That will give us r squared. 56.8 times 3 over 3.6 pi. So that's r squared is 15.066. And then r is going to be 3.88158. I'm going to store r in my memory. Let's store that in memory slot A. So we've now worked out the radius of this, and we're told the height. So we need some connection between the sector so that we can work out this angle. Now the connection is kind of given us here, because the curved surface area of the cone is going to be equal to the area of this kind of shape here. If you can imagine folding this up, this AOB, this becomes this sort of left-hand edge here, but it's in 3D. So they join together to make the cone, and the circle ACB, that sort of circular bit, becomes the base of the cone. So we need to do some Pythagoras on this to find OC, which will be the radius of the sector, because OA, OB, and OC are all the same length. So OC squared is equal to h squared plus r squared. So OC is going to be the square root of that. So 3.6 squared plus our radius, which I stored in A, squared. And then I'm going to square root the answer. So OC is 5.2940. And I'm going to store that in the memory B, so I remember where everything is. Okay, so OC is the slant height there, but that is also the radius here. So 5.29. We now need the area of this whole sector, which we can get from pi RL, curved surface area. We've just worked out OC, which is also the slant height here. Okay, so the curved surface area is pi times the radius times the slant height. So pi times the radius we worked out, 3.88, and then the slant height, which we just worked out, OC, 5.294. So that's going to be our area. So pi times the radius, which I stored in A, times OC, which I stored in B. I'm trying to use the exact values. 64.557. I'm going to store that in C on my calculator. So I now know this curved surface area, which is all of that. So I can use my formula, theta over 360 times pi r squared is the sector area. And I know the sector area, I've just worked that out. So 64.557 is equal to theta over 360 times pi times the radius squared. The radius is actually OC, not the radius from the cone. So OC was B, which was 5.29 squared. Tricky. So we can rearrange this. I'm going to times both sides by 360 and divide by 5.29 squared pi. That should give me my angle, hopefully. So I'm going to divide that by pi and then divide that by OC squared. 264 degrees to three significant figures. Okay, 264 degrees, 3/4 of a circle. That looks about right. I know it's not to scale, but it's not ridiculously out. So 264 degrees to three significant figures. Hopefully that is the right answer there for you guys. Okay, question 24. Got a parallelogram. O to X is A and O to Y is B. P is the point on OX, so that OB to BX is in a ratio of 1 to 2. So add those up, we get thirds. So this is A over 3, and P to X is 2A over 3. And then O to R, so that's in quarters because you've got a 1 to 3. So we've got B over 4 and 3B over 4. That gets from R to Y. Work out in its simplest form the ratio ZP to ZR. Okay, so let's work out ZP. To get from Z to P, we have to go A to get from Z to Y, and then minus 3B over 4. That gets me from Z, oh, that's ZR, sorry. So that's ZR. So I've gone A to there, A, and then minus 3B over 4 to there. Sorry about that. Let's do ZP this time. Let's see if I can get this right way around. So I need to go A to get to Y, then minus B to get to O, then I have to add A over 3. So I can collect that together and I get 4A over 3 minus B. So the ratios of these things, what we do with ratios is they're fractions, as you know, ZP to ZR. I'm just going to look at the A's first. So for ZP, I've got 4A over 3. And for ZR, I have 1A. Okay, so I can times both sides by 3. 4A to 3A, I've got a ratio of 4 to 3. And if I've got this correct, I'll get the same ratio when I compare the B components. So ZP was negative B, and ZR was negative 3B over 4. So I can times by minus 1, that's fine. And I can times both sides by 4. 4b to 3b, cancel the b's, and I get 4 to 3. Okay, so the ratio of ZP to ZR is 4 to 3, which kind of makes sense. It's like a third bigger if you look at ZR. Yeah, that should work. Okay, that's the end of the paper. Right. So hopefully you found that useful. Plenty of questions there, plenty of tricky questions, which will challenge you and hopefully give you a bit more practice before January.